Hello, everyone. How's everybody doing? I hope you're doing fine. Here we are, another day, another night for me. I don't know if it's day over there. Um, there we have a good day, hopefully. And first, I want to remind people we have a conference in Lusaka, Zambia. Okay, and that's going to be at the end of the month. We're about a month away from this. Okay, so you're going to go get your tickets, uh, your bags ready, all that stuff, right? Gonna have a good time over there. Gonna drink some Zambian beer. We're gonna try it out, see how good it is. Want to remind also people that we've uploaded a book. It's the Rope Hypothesis, and this book brings you up to speed on the rope model. Specifically, what we're doing here with this book is explaining all the invisible phenomena. Okay, we're explaining light, certain behaviors of light, the most common behaviors of light. We're explaining gravity, electricity, magnetism, and the workings of the atom. Okay, and you can find it at that site, ropehypothesis.com. You just go to books there, and you'll find a link to download the PDF file. Okay, those who wish to translate it, again, I want to remind people that you're welcome to contact us at tokakaka@hotmail.com and let us know if you have a second language you want to translate it. We have already a couple people doing that for a couple languages, and I'm translating it into Spanish. Hopefully, I'll finish one sometime this year. Now, it should be soon that I put it online, okay? So what's the day about? Well, today I want to continue where I left off the other day, okay, and that was light. And I didn't get to finish the whole story, and I want to fill in the blanks, make sure that we get the proper message across of what I was trying to say last week, the main points, okay? So let's go with that. Let's start there. Uh, oh, I got this so big. Hold it. Let's get that down to size. Okay, and this is what I was trying to say the other day. Yeah, that's fine there. Uh, the main points were that mathematicians, the people who run the world, they make the following claims. They say that when light passes from a lighter to a denser medium, one that is rare, one that has less density and goes to a denser medium, like from air to glass. That's the typical example. They say that light slows down. Light travels at a different speed. Okay, that's the uh, official version. To calculate the speed of light through the denser medium, the mathematicians invented an artificial parameter known as refractive index. Now, I've used refractive index for many years because we use it in the semiconductor industry every day. So we used 145 for glass. The typical value out there is 1.5. It's better to deal with 1.5 because it gives you almost a perfect 200,000 kilometers per second for light going through glass. The question is whether that's real, whether that's what actually happens when light goes through glass from air to glass. Does that happen? Does light slow down? Okay. And the alchemists explain that wavelength shortens. The wavelength becomes shorter, okay? And frequency is unaffected. Frequency remains the same. What changes only the wavelength. And because the wavelength shortens, right, the speed of light shortens. That's the official version, okay? And gullible individuals who follow the mathematicians and don't know any better, they extrapolate that since color is a function of frequency, remember, frequency doesn't change, right? Wavelength going to change. The color of light does not change as it passes through the denser medium. Okay, I hope that's understood. They're saying that light goes from air to glass. Okay, glass is a denser medium than air. There's a gas, right? This is, they call it a supercooled liquid. They've got all types of names. It's a solid for sure. okay? Because you touch glass and it's kind of hard, right? And they say when it goes from the less dense to the denser medium, what changes is only the wavelength. And so these people say, well, since color is a function of frequency and not of wavelength, then color does not change when it goes through the denser medium. This is the worldly wisdom today. Okay, so I hope that's clear as what we tried to say the other day. Okay, what's wrong with all this? Okay, let's go with the first one. This is what they're saying. Okay, they're saying that light comes in there. Okay, into a glass. It comes from air, which is the bluish part on the outside, goes through glass. Okay, and it goes slower. They claim. They claim that it goes slower through glass, about 2/3 slower. It goes 300,000 kilometers per second in the blue part, and then when it goes into this whitish area, it goes at 200,000 kilometers per second. Why? Because the electric field slows it down. It mingles. The electric field mingles with the light, field of the or the electric and magnetic fields of the of light, and it slows it down. Okay, so how did they ever determine this? Okay, they did it mathematically. Okay, that's how they did it. And this is the official version here. You have two representations, two statements made by people at the Stack Exchange, which I mentioned the other day, and the third one comes from the Wikipedia. Okay, and they all say the same thing. I just want to establish that this is the official version. Okay, just so you know. Okay, when a beam of light crosses the boundary between two mediums, its frequency does not change. Its wavelength changes. Okay, so it is not an experimental fact. Now we're talking about facts. This is proven, and you got to take it to the bank. Okay, that refraction does not affect color. So they're saying two things here. Not only does the wavelength change, but color does not change because frequency doesn't change, and they claim that color is a function of frequency. Okay, so one can conclude that color is frequency dependent. Another fellow says the frequency of a light wave does not change from medium to medium, while the speed of light and thus wavelength does. Okay, I hope it's clear. Okay, by knowing the frequency of an electromagnetic wave, you know its color. In other words, since frequency doesn't change and color is not going to change, right? In any medium, the color of an electromagnetic wave is defined by its frequency. So they claim that frequency does not change when it goes to the denser medium because, color doesn't change because frequency doesn't change. What changes only the speed of light because wavelength changes, shortens, okay? And then Wikipedia confirms all this. The refractive index can be seen as the factor by which the speed and the wavelength of the radiation are reduced with respect to their vacuum values. In other words, if you compare glass or any other material, but glass is a good example. Glass versus vacuum, which you would find out there in space. Well, they claim that light travels slower through glass. Okay, what's the reason? It says the speed and the wavelength of the radiation wavelength, right, are reduced with respect to their vacuum values. The frequency of the wave is not affected by the refractive index. Okay, frequency doesn't change, remains constant. Because color is a function of frequency, according to these representations, color doesn't change when it goes through a denser medium. The only thing that changes is the wavelength, which means that what's going to change is the velocity of light. And so we got to find out where this all comes from. And here you see the equation, okay? You don't need to be an expert in physics or math to understand this. Velocity of light, little c, 300,000 kilometers per second, is equal to wavelength, which is that lambda, times frequency, the little f there, okay? That's the equation. It's a constant, little c. But they claim it's a constant only in the vacuum, okay? Only in the vacuum, okay? So keep that in mind. So in the vacuum, we have 300,000 kilometers per second. And I gave an example here. This is just an example. We have the color red, 650 nanometers. That essentially is the color red. That's the wavelength. 650 nanometers is the wavelength. What's the frequency? 4.6 terahertz. Okay? Okay, so that's in the vacuum. What happens when it hits SiO2, glass? Okay, well, the refractive index is 1.5. That means you're going to divide 300,000 kilometers per second by 1.5. That gives you 200,000 kilometers per second. That's how they get that number. Okay, what changed? Did the frequency change? No, it's still 4.6 terahertz. And what does change is the wavelength. That's what they're claiming. Okay, so I hope you understand that much. Wavelength changes. In fact, it shrinks, it shortens, and because it shortens, light travels at a slower speed. Frequency remains the same, and since color is a function of frequency, they claim that color does not change either. They claim that to have proven it experimentally. Okay, that's the official version. Okay, let's find out what's wrong with all this. Okay, here it is. First, so you can visualize what they're saying. Okay, you can see the waves of light coming into the glass. That blue part is glass. Okay, the waves of light, electromagnetic waves, because they have to do it with waves. They can't do it with particles, right? They have these waves come in and they flatten out in the direction of travel because what they're saying is the wavelength shortens. But you can see the frequency remains the same. I put 3 lines there to show you that the same number of waves pass through that given point. Okay, the same. So frequency doesn't change. What's changing is only the flattening out in the direction of travel of the wavelength. Okay, and so yeah, this is where we have this is what they're proposing. Okay, and we have a couple problems. The first one is this the spectrum. Okay, the spectrum, the color spectrum, okay, is always given in terms of wavelength. It's not given hardly ever in terms of frequency. Some people put it in terms of frequency as well, like that first one. But the second one is the more common. You'll see it only under wavelength. Wavelength, in other words, color changes with wavelength. So if you change the wavelength, you change the color. These people are saying that when light goes through a denser medium and it flattens out, in other words, the wavelength shortens because light shortens, they claim that light doesn't change. Well, that violates the visible spectrum. Not to mention the entire spectrum, but also the visible spectrum. Under the rope model, very easy. It's a piece of cake, no problem. C equals lambda times frequency is the equation of a rope. It can only be modeled by a rope, okay? Well, I don't know, maybe someone smarter than me can find something else that models it. But here you have it. You have how many links there? If you count the blue ones, you have 4 links, okay, more or less. And if we untorque it, okay, now you have what? 2 links, and each link is longer. So you have fewer links, frequency, okay, and greater wavelength, okay? The wavelength is longer. Now, if you torque it one more time, right, you get more for the same amount of rope. I haven't changed the rope. This is it. This is the whole thing, okay? Now I have shorter links, and and you have more links, okay? So now you see why velocity of light never changes anywhere in the universe, no matter what material it goes through, because the theory that we're proposing is that the rope binds any 2 atoms. And so the only thing they can do is torque and untorque. It can have longer link lengths and fewer links, or more links and shorter lengths. That's it. And that's what you see at the bottom there. That's the spectrum according to the rope model. You can see it fits perfectly there. We have no problem with it. We don't have to shorten the wavelength and keep frequency the same. Okay, that's the point that I'm trying to make. And the other point that I want to make is that color is a function of wavelength, which these people are saying it's not. So it contradicts the spectrum. And this spectrum has been, I mean, you can look it up on your own. You'll find it everywhere. So they have to explain why, if wavelength changes, why doesn't color change if color is a function of wavelength? So this is the first problem, that they have a contradiction. They have to resolve that contradiction. Okay, that's the first issue. Okay, what's the second issue? Well, the second issue is, why does the wave go slower? And these people are saying, okay, the reason it goes slower is that the wavelength, the wave of light, which is the first one there, the one that's coming into the glass, right, hits the electrons of the atoms that comprise the glass. And what happens is the electrons now start waving as well. And they mix. You have the wavelength of light mixed with the wavelength or the waves of electrons, and they slow them down. Okay? And the problem here is that first, there is no such thing as a wave in science. A wave is a verb, not a noun. Okay, there's no such standalone object called wave. And that's the first thing that destroys their whole argument. But then, assuming we concede the wave, what is the mechanism? Why does in other words, why does the electron wave slow down the light wave, the waves of light? We have no reason, we have no mechanism. All they say is it is so, and that's it. So this is the problem. And the other issue here is that, when the waves go back to air, well, air is full of all kinds of, particles as well. I mean, what is air? Isn't air a bunch of atoms, a bunch of molecules? And if it's a bunch of air, if air is a bunch of atoms and molecules, what's different about them from the others? From the electrons that form the glass? What is the difference? In other words, why doesn't you're going to look at a big difference here. You're saying that in the case of air, light travels almost 300,000 kilometers per second. Travels almost, according to them, it travels almost at the same speed as through the vacuum. And through glass, it goes much slower. It goes at 200,000. Okay, that's the problem. And you're saying, well, what's different about the medium? I mean, between these two, between air and glass. I mean, air is also made out of electrons and atoms and molecules. So they would have to explain what the difference is. And they don't do it. They just say, it is so. So we have a problem in that we don't have an explanation, a mechanism of why light slows down. And you'll never have it with the word wave, because wave is not a physical object. You cannot use the word wave as a physical object, which is what they're doing here. They're saying there is something called a wave, and this wave clashes against another wave. That's like saying love clashes against intelligence, and it slows it down. What have you learned? You have two concepts. That's all you have is concepts. These people are juggling concepts and saying, oh, we have one concept hit another concept. That's all they said. Okay, we don't have objects. And hopefully air is a physical object. It's made out of atoms. Okay, it better be something physical. And glass is also made out of, is physical. So you have to explain this in physical terms. You have to illustrate it and not say wave, and wave of what? What's waving? That's what you got to identify. Otherwise, you have no mechanism. And that's where the problem is. Okay, so what is our model? Well, very simple. You can see straightforward. None of that nonsense. The rope is connected to an atom, and here we only show one atom. Okay, and the atom pumps back and forth, doing its quantum jump. By doing so, it torques the rope, and now you can see why it goes slower through glass than through air, because what we have here is that the atoms are in a crystal lattice, and so they don't pump as hard as they do in air, and so the wavelength is what changes. But now we have a mechanism, because we can say, look, what we've traded here is link length for the number of links. That's what we did. So now you can visualize why light slows down. You can't do that with a wave. I mean, what's the problem with having the wave increase both frequency and wavelength and travel faster than light? There's no impediment. Mathematically, you can do it. But physically, what's the physical cause? And here you can see the physical cause. You cannot trade wavelength for frequency other than like what happens in a rope. Either you have more links and each link is shorter, or you have longer links and you have fewer what is called as frequency. Okay. And you can see that it fits the equation perfectly, the wave equation. C equals frequency times wavelength. One goes up, the other one goes down, period. We're done. So it's straightforward, none of this nonsense about waves and about magical interference between two waves, whatever those are, no explanation, no mechanism. You're as blind as you came in, you don't learn anything with these people because they don't have a mechanism. They just say it is so. And again, they hold frequency constant artificially, and they say, well, light goes slower, and that's it. Take it or leave it. That's the way it is. The other thing I wanted to address the other day is this fellow Tanamura, and what he did. He says he claims to have manipulated one electron at a time. He said these spots indicate individual electrons, doing the slit experiment, right? Electrons are detected one by one, and you can be confident that that electrons are particles. Okay. And then, of course, he reaches a crazy conclusion. He says, when accumulated interference fringes are formed, and we have reached a conclusion which is far from what our common sense tells us. No kidding. And the reason is because he's doing this with bullets. Okay, so what is Tanamura doing? Well, he thinks he's in the thinks he's in a shooting range. If you give me a second here, you'll see it come up. And he thinks he's shooting bullets. Okay, and that's how he's going to make his fringes with bullets. Okay, he just shoots a bunch of bullets. He claims to have handled one bullet at a time. Okay, and that's how he makes his interference fringes. You see it here. That's what he claims is doing. And he says, well, you can see that it's obviously they're bullets. I mean, what other conclusion can you reach? What other possibility is there? Well, let me enlighten Mr. Tanamura, okay? Here's another possibility, okay, for you to consider, okay? How about drilling? We drill the holes, okay? Is that a possibility that we just drilled them? Okay, we drill holes, and here you'll see them. Are those bullets or are those drilled? Can you tell me? So maybe he drilled those holes into the wall. Has he ever thought about that? The possibility that there's another mechanism that does not involve bullets? So this is the issue. These people are dealing with bullets for the last 400 years, more. I mean, even in the days of the Greeks, they were only talking about bullets. The only time they introduced the wave was when Robert Hooke, in the 17th century, wrote his book Micrographia. I think it was 1665. I think it was, and he talked about waves, light being made of waves. Then Christian Huygens, a few years later, he got a hold of that idea and he started playing around, with waves of water and try to explain light in terms of water waves, and he got into a little struggle there with Newton, who said, no, light is made of particles. They all said particles because they all vouched for the ether. Both Newton and everyone in the 17th century dealt with the ether. What's the ether? A bunch of particles. That's what the ether is. And Newton said, light travels through the ether. And the other guy said, no, it's the ether that's vibrating up and down. And that's where they ran into trouble. Okay, they had a little clash of philosophy there. And to this day, no one has fixed that problem. Okay, so what is the problem with Tanamura's version of bullets being shot at the target? Well, here you have a chamber, okay, and we have electrons. According to the official version, we have electrons flowing from one atom to another, and this is what the mathematicians call electric current or electricity. They say it's the flow of electron beads. They call them charges, which is another concept, but they're thinking of balls. They're thinking of this little tiny ball which has no dimensions, no size, it's got no volume. It's called an electron. This nothingness goes from atom to atom for whatever reason. They have no idea why it goes there. It just says, well, when you put a potential, it just does it. When you put it within a voltage, these little balls flow. Okay, let's assume that's true. What happens if we remove the atoms from the chamber? Okay, we remove more atoms. Can you flow only electrons across that divide? Can you just shoot electron bullets like Mr. Tanamura claims that he's done? Okay, that's the question. Can he do that? Can we remove more and more matter? Can we pump the matter out of the chamber, right? We pump it down as electricity is flowing. will current stop flowing at some point without doing anything else? We just have a current flowing at whatever, we have two plates there. We have current flowing from one plate to another, and we pump down the chamber gradually as much as we can. Hopefully, if we could take it to a minus 12 torr level, it'd be great. Would current would current stop or continue flowing? That's the question. And even before that, Mr. Tanamura has a serious problem. And the serious problem is this one, okay? This is where the problem is with quantum mechanics. We need to know what keeps the electron bound to the proton before he sets the electron in motion, before he ionizes, before he turns it into a little bead that's going to be part of electricity. We need to make sure that electron is first attached to the proton somehow. And I'm using the hydrogen atom, obviously, because it's the simplest to understand. I mean, we need to know what's in that brown region in the center between the electron and the proton. What is that region? What's holding the electron there to begin with? What are they going to use? A concept? Are they going to put an elastic band? Are they going to push the electron by particles from the outside towards the proton? How are we going to do this? And this is where Tanamura has to start. He says he handled one electron at a time. Before he can handle an electron, he's got to show me, what an atom looks like. And you have more bozos. Here's a group of bozos from Sweden. We have these two bozos, and they claim to have filmed an electron. Okay, so they filmed an electron. I hope Mrs. Ann and Mr. Johan can draw an atom for me before they can tell me that that's an electron that they filmed there. What did they film? I mean, if that's an electron, we got a problem. First, because the official version is that an electron is a point particle. It has no volume, no size, it's a nothing. That's what it is. It's a point particle. They don't know the size of the electron. These people claim to have filmed it and measured it. Okay, fine. Let's concede that. What does their atom look like? I mean, if they can film an electron, I'm sure they can tell me what an atom looks like. And if they can tell me what an atom looks like, does it look like the planetary atom that Mr. Bohr and Mr. Rutherford came up with at the beginning of the 20th century? 1911, 1919. They built this atom, this planetary atom. What holds the electron to the nucleus? That's all we need to know. And if they can't answer that question, they can't even start their presentation because they don't have an assumption. They don't have an object to begin with. So they can't just continue to their theory about electricity and say, well, ionization is this and electricity is that, if they cannot tell me how the electron remain faithful to the proton to begin with. So all they need to do is draw their atom. That's how simple it is. It's very easy. And if they filmed and photographed and interviewed an electron bead, well, they should be able to give me an atom, right? Just draw it for me. I mean, how difficult can it be? We got a big ball, a bowling ball called the proton. We have a little bead called the electron. I think I could draw that. I mean, it's up to them. I don't want to put words in their mouth, Yeah, they need to draw an atom. And if they can't draw an atom, if they continue with their planetary atom and they say, well, we use the planetary atom to explain electricity, we got a problem. No, we got to take one step back and find out what an atom looks like before they move the bead. Okay? That's the issue. And so, yeah, this is what Mr. Tanamura says he did. He says we have this planetary atom, and the question is what keeps that electron bead tied to the proton. That's the only thing he's got to answer. What's between the electron and the nucleus? Okay? Because that's the whole problem. That's the whole problem with quantum mechanics. That's why they can't make sense of any of it, because they cannot explain this. They cannot explain other with through magic. Okay? What binds the electron to the nucleus. That's where quantum mechanics dies, right there. In the atom. They have no picture of the atom. They have pictures of everything else. They have pictures, like I showed the other day, they have pictures of the gluon. They have pictures of the quarks. They have pictures of the electron, but they don't have a single picture of the hydrogen atom. No one can draw in a hydrogen atom for me. In fact, I had a debate a few years back, one of my first videos, shows, I contacted these guys from the universities, professors and so on. Not one could draw an atom. They said, well, we don't know what an atom looks like. You know what an electron looks like, you know what a gluon looks like, you know what a quark looks like, but you don't know what an atom, which is the big house, you don't know what that looks like? Nonsense. They never photographed anything. They make outrageous claims. That's what they do. And a lot of people are gullible and they swallow all this, like candies. Okay, but today I'm going to talk about something else. I'm going to do a seance. So right now we need total quiet because we're going to be invoking spirits right now. Okay, we start what? We start with the golden rule, the golden principle of physics. You can't do physics without an object. If there's nothing in the universe, there's nothing going on. There's no motion, there's no nothing. If you want to do physics, you got to start with objects. You got to have something there. That means all the mediators of gravity, of light, of magnetism, electricity, they had all better be mediated by objects. You cannot use concepts to mediate two physical objects. You cannot say that love pulls a horse to the cart. No. You want to have the horse pull on the cart, you got to put some pieces of wood tied to the horse. Then we can all understand the mechanism. But if you say, look, the horse is over there, the cart is over there, and when the horse moves, the cart moves, what's in between? I don't know, force, energy, perhaps mass, time? No. You have to put a physical object. Then we can understand the mechanism. If you're going to put a concept, you're not doing physics, you're doing religion. We need to explain mechanisms. People don't understand what that means. So yeah, physics requires an object. The first thing that a physicist must do is define the word object. The word object is absolutely indispensable in physics. You need to know what an object is. We define it as that which has shape. And what I said the other day is that, anyone who really wants to challenge the rope model has to start there. They have to start at object. They have to define the word object. So far, no one has done so. They have to do it in that format. Object, colon, and a few words after that defining what an object is. Just like I did here, okay? Just like I did here, see? See how easy, how straightforward that is? No hidden thing. I'm not going to explain it to you. No. There's the definition. Object equal, okay, or colon, that which has shape. Straightforward. Now you can challenge it. You may not like it, fine. But you got a definition. I need a definition from whoever challenges the rope model first. That's where they should start. And of course, everybody wants a challenge, but no one wants to define. And then we have a problem because the problem is that people don't know what an object is. No one has defined the word in the last 10,000 years. And second, no one has defined the second important word, which is the word exist. Everybody talks about what's real, what exists, and nobody defines what real and exist mean, what that word means, what those two words mean. Okay, they're synonyms, but that's why I said word. Okay, one guy gave it a shot. Okay, and here it is. I'll just go quickly through this. He said, it's not true that philosophers have never defined object. They have. Oh, okay. Only what you call object, they call being. Ah, is that what it was? I must have missed it. Substance, real entity. Okay, and mention someone. You may disagree with their definition, but they have them. No, they don't. That's not a definition. Okay, and let me tell you why. Being is not a definition because when you look it up, you find this. Okay, you look up being, and it says the fact of existing, existence, something that exists. So in other words, they're saying that, and this fellow is saying that, or the philosophers are saying that being and object are the same, and if being is exist, then he's saying that existence is the same thing as an object. Okay, that's what they're saying. Well, what's the problem with that? Well, let's look up exist. Let's see what exist means. Well, if you look it up, it says to have actual being. So being and exist are synonyms. We have no definition as of this moment. Philosophy, if you go into the dictionary, it'll give you definitions applicable to philosophy. It says actuality. What is actuality? Existence, reality. What is existence? Well, again, you get back to the same synonyms. That's all you do. You go around in circle. Wikipedia, the material or immaterial existence. That's what being is. You look up another place. Existence, I think it's part of the Wikipedia. I'm not sure now. Existence is the ability of an entity to interact with physical or mental reality. I thought reality was a synonym of existence. And then they continue, in philosophy, it refers to the ontological property of being. So all we have is synonym. We have existence as reality, reality is being, being is existence, and all the actuality. We don't have a definition. All we have is synonyms. And so we don't have a definition of being, and so we don't know what a being is, and you can't say that an object is being because they don't have a definition of being. We're done. Okay? Until you get a definition of being, exist, actuality, reality, whatever you want to call it, we don't have a definition. And for sure, we already pointed out that Hume and David Hume and Immanuel Kant could not tell the difference between existence and object. And that's the same problem we have with being. They can't tell the difference. And again, an object, does a square exist? Well, the answer is no. It doesn't exist. Superman does not exist. So there are objects that don't exist and they don't have being. Okay? So no, you can't use the word being to define the word object. Sorry. Okay? And again, it's because it's irrational, not because I say so. And when you look at the Stanford Encyclopedia for object, you find this. I mean, you can look it up. It's so funny because the philosophers, the so-called philosophers, these morons who work at Stanford, the whole encyclopedia is just garbage. Every article that I've read so far has nothing in it. And when you go to object, you find this. You find all this discussion on all these possibilities. It just blows your mind away. These guys have been going around in circles for the last 10,000 years, just talking about nonsense, ontological, about existence, and all we're trying to find out what an object is. And then they talk about what objects do, what objects are. You should. It's really better than stand-up comedy. If you go there, you'll see what I mean. It's just absolutely ridiculous. Okay, and so yeah, in physics we have to define the word object, and what we cannot use in physics to move things around are concepts. And here are the most famous concepts. Okay, we cannot use these words in science. These are words of religion only. Anyone using any of these words to try to explain, or terms to try to explain a phenomenon of physics, a mechanism, is doing religion. Any of those words that you use, okay? Because none of those are physical objects. All of them are concepts. Okay, this is where it starts. Okay? Okay, onward with our seance now. Okay? Very quiet. Okay, you had the introduction there. Okay, here, let's go with it. Okay, this is what we got to explain. Okay, we have a situation. Okay, I want you to explain the mechanism. That's how you get the beer. You can explain the mechanism, okay? Otherwise, you don't get the beer. You lose a beer. You got to pay me the beer, okay? It's the other way around. So we're betting a beer here, okay? Who gets it, okay? And here it is. This is the situation. You have an astronaut and he falls to Earth, okay? We have to explain this phenomenon. We call it gravity, okay? Call it whatever we want, no problem. We can call it X also if you want. But let's call it gravity so that we're all more or less on the same page. Now we got to explain it. Now we have a group of people here all holding hands around the round table, okay? And one of them is Catholic, okay? He's a Catholic and he says, I can explain it. Oh, okay. What's the explanation? And he says, look, an angel is pushing the astronaut towards Earth. That's the mechanism. You don't see the angel because you can't touch an angel. You can't see an angel. The angel is pushing the astronaut to Earth. And he goes there and he illustrates it for us, okay? So now we see that there's an angel and he's really pushing the astronaut towards the Earth. Okay, we can all understand that. Okay, but the atheist comes in and says, but I don't believe in angels. An angel's not an object. An angel is a concept. And so you haven't explained the mechanism. Well, the atheist would be wrong on all counts. He's simply wrong. He doesn't understand the mechanism. He doesn't understand the scientific method. That's why he said such dumb thing. first of all, an angel is an object. It's not a concept. Okay? And this comes to the issue of people not defining terms. What is an object? It's that which has shape. Did you just see a shape there carrying the astronaut? Don't you see something with wings there, or do you only see an astronaut? Because if you only see an astronaut, you got a problem with your eyes. You got to go see an ophthalmologist. Okay? There's something there. We call it an angel, and that angel's carrying the astronaut to Earth. So not only is an angel an object, but the mechanism is clear. The angel is pushing the astronaut to Earth. So what is it that the atheist doesn't understand? We have every element that we need. We have an object called an angel, and this angel is pushing the astronaut to Earth. We understand the mechanism. Now the person says, well, I don't believe in angels. That's a different story. Now you change the subject. See, the conference is about mechanisms. And the religious individual is saying, look, I believe in angels. It doesn't matter if he does or not, but he says, let us assume there are angels. Okay? The angels are untouchable, unseeable. Okay? But they have shape, obviously, because he made it visible for us. He made the angel visible so that we could see the mechanism. Not that we can see angels, but he made it visible. And now he shows the mechanism. He shows the angel pushing the astronaut to Earth. Okay. We understand the mechanism, and he used an object, an angel. Do you believe his theory? Well, that's up to every person. Some people believe, some people don't. That's a separate issue. Now we're talking about belief in existence. What you believe exists out there. That's a separate matter altogether. Doesn't even enter the picture. Right now we're only concerned about mechanisms. And the mechanism was clear. The angel carried the astronaut to Earth. Now you may say, why does it go faster and faster and faster? Why does the astronaut fall at 9.8 meters per second square? You can go through a lot of stuff and criticize the mechanism. But you cannot criticize existence. You cannot criticize the assumption of existence, because that's the way it's done in science for invisible, intangible, untastable, unhearable, unsmellable entities. You have to make an assumption. Okay? And no, don't go to the lab to try to prove if angels exist, because the guy is telling you they're untouchable and unseeable. So you're not going to detect angels with an experiment. Okay? So let's understand the scientific method first, because that's where people have problems. People think that scientific method is about believing in existence. Oh, I don't believe in angels. No, it's got nothing to do. I don't care if you do believe in angels or not. It doesn't matter. Okay? It has nothing to do. It's irrelevant, your belief. Okay? The guy proposed an object and he showed the mechanism. Period. We're done. Okay, now comes another religious person. He's a Protestant. Okay? He's not a Catholic. He's a Protestant. He says, oh, no, it's God. And he makes an assumption. He said, okay, the other guy made an assumption about angels. I'm going to make an assumption about God. I'm going to say that, let us assume that God exists. Okay? And there you see what he proposes. Well, I got a problem here. This time I do have a problem, because now God is doing something from action at a distance. I don't see what the cause is from the finger to the astronaut. I don't see the mechanism. All I see is that the guy's pointing at the astronaut, and the astronaut falls to Earth. I don't see what the mechanism is. Do you? And so the guy said, well, you don't understand. You see, God is omnipotent. He has superpowers. Well, yeah, now he makes that assumption. He says, God is all powerful. He can do anything he wants. So how should I take that? Well, yeah, then you bring Billy Occam. You bring Billy Occam, you say, look, you apply Occam's rule. You say, well, the least assumptions. And here he's making a whopper of an assumption. He said, yeah, I mean, if you're going to say that God is all powerful, we don't need a mechanism, because that's what he's saying. He's saying he doesn't have a mechanism. He just says God is all powerful. Is that an explanation for a mechanism? No, I don't see the mechanism. With the angel, I saw the mechanism. I saw push. So at least I understood the mechanism proposed by the angel theory. But the God theory, I don't see it. I just see magic, black magic. And yeah, some people believe it. Okay, go ahead and believe it. I'm just saying, how it works in science. Okay, that's the point that I'm trying to make here. Okay, now we have a really retarded individual, and he comes from mathematical physics. And he's going to do it not with God, not with angels. He doesn't believe in all that nonsense. No, he's going to introduce force. He says, I'm going to do it with force because force is a physical object. So he has force pushing on the astronaut. He says, I do it with force. Well, now I have a big problem because now we're not talking about an angel pushing. Now we're saying there's a concept he calls force. And he's going to push the astronaut with this concept. And he says, no, but force is a physical object. What do you mean it's a physical object? All I see is a bunch of words there. What is force? Can you draw it for me? I want to see a surface-to-surface push there. And I don't see that. All I see is a bunch of letters pushing on a guy. And this is where we run into trouble with the mathematical physicists. Because what they want to do is use concepts. The concepts I mentioned earlier, they want to introduce concepts and do physics with concepts. They want to push energy around and warp time and push the force and draw the mass. No such things. So you can't do physics. You cannot explain. You cannot give a physical interpretation to a mechanism using concepts. That's the issue. And here, let me show you. This is what you would have to present to a mathematical physicist. Okay, you would present something like this. You would show them, say, look, here we have a seesaw. Okay, why does it go up and down? I mean, what is it? We have black magic there, or you present something else, something similar, another phenomenon, common phenomenon. Here you have, a box that just goes up. And you say, how does it do it? I don't see anything. I can't touch anything. It just goes up. It's by magic. Is he going to put force in there? Is that what he's going to do? Is he going to just put some kind of concept in there? Is he going to say love pulls on the box? And here we have our famous fella, Felix the cat. And he's going to wave his arm, say abracadabra. Okay? Going to wave it, abracadabra, and he breaks the window. Did you see how it broke? Try it again. Let's look at it one more time. Okay, so Felix waves his magic wand, whoop, and breaks the window. So what broke it? A concept? Was it force? Well, let's see. Here we can see how Felix broke the window according to mathematical physics. He did it with force. Oh, I see. So he sent the force through the window. A bunch of a 5-letter word, really a 4-letter word, but yeah. Okay, so is that what broke the window? Force? And so now you see the problem. Now you see why we need objects, because we can't see what happened here in any of those cases. We don't know how the seesaw went up and down. We don't know how the box was lifted or pushed. We don't know how the window broke, because they were all invisible intent. We can't see what happened. And so how are we going to do this? Are we just going to introduce some concepts and say, well, here it was mass, and over there it was energy, and then over there it was force, and then a field came over, and then charge moved up and down? Is that what we're going to say? Is that how we're going to explain how these things happened? We don't do that because we can see every object in our ordinary lives. And yeah, when you go in there, right, you get these situations where you are able to explain it because you see them. And so you say, okay, how did the seesaw go up and down? Well, here you see it. Okay, there were two fellows there, going up and down. We can understand it, because you say, oh, okay, it was these two guys that were on the seesaw. No wonder it was moving. We couldn't see them before. And with the box, we can see the pulley now. Say, oh, okay, there was a rope. That's what it was. We couldn't see the rope. So if the rope is invisible, are you going to put a concept in there and say, oh, the box went up because of a concept? And Felix, yeah, we can get an idea how that thing broke, how the window broke. He had a horseshoe, twirled it around, and then he throws it. Now we can understand how the window broke. Was it magic? Do we need black magic to explain this? No, of course not. Now it's straightforward, because now you saw the object. And that's what we got to do. We got to make the invisible visible. And then it's kid stuff. It's kindergarten stuff. But if you use concepts such as mass and energy and all these four-letter words that they have in mathematical physics, then you're not going to understand anything because they're using a concept to give you a physical interpretation. That's the issue. Okay. Okay. So there are other people and in the CNs, and these guys say, no, it's the ether. We do it all with particles, the quantum way. Everything is done with particles. Well, again, I got a problem here because I don't understand the mechanism. All I see is a bunch of particles. The guy's falling. Why is the guy falling? Because the particles are everywhere. And so what these people have to do is say, well, some particles are coming from over here and not as many from over there. And they try to find mechanisms to try to explain that difference. Okay? Well, the problem here is that we don't know what this ether is. And so I had to define it for them. You look it up. Let me put myself back in here. If you look it up, you'll find this. Dictionary, ether, a hypothetical substance, okay? Supposed to occupy all space, postulated to account for the propagation of electromagnetic radiation through space. You go to the Wikipedia, in physics, ether theories, also known as ether theories, okay, propose the existence of a medium, a space-filling substance. Space-filling. It fills space. What could fill space? Particles. That's what they're thinking. They're not thinking that space is made out of a single piece because no one would be able to move. No. Ether is particles. That's what it is. And this is space-filling substance or field. What is field? Another concept. So space is filled with concept. It's filled with love. That's what's going to do the trick. That's what field is, a bunch of numbers. Values, that's all it is. That's what the word field means, values. That's it. A field of, it's a bunch of, it's a beehive of numbers. That's what of values. Thought to be necessary as a transmission medium for the propagation of electromagnetic or gravitational forces. How does Bill Gates define it? Ether, bunch of particles. That's what they're saying. They're saying that ether is a bunch of particles. The only issue is whether space is filled with particles, like if space is a container that gets filled with all these marbles, or whether space is the ether, in which case space is made of particles. And if it's made of particles, you got to tell me what's in between each particle, what delineates, what encapsulates each particle. If space is made out of particles, are the particles perfectly cubic, so they're surface to surface? And even in that case, if we have cubic little particles, you got to tell me what separates one cubic particle from another cubic particle, even if they're face to face. Because otherwise they're just one particle. If you have two particles, then there's something separating them. And you got to identify that something. What is it? What separates particles of space? So you got a problem either way. Either space is a container that contains marbles, or you have all these particles in there. Let's make them cubic to make it very simple for them. You have cubic particles face to face. What separates each cubic particle from the other one? That's all you got to answer. If you can answer that question, well, you get a beer, okay? And yeah, we need rational answers, not some stupid thing. Okay? Now, the relativist, he says, I can tell you how the astronaut comes down to Earth. And he says, look, he slides along space-time. That's what it is. There he goes. It's a slide. So he slides down to Earth, right? And so we got a problem because space-time, they're saying that time is warped. You're saying, what do you mean time is warped? See, if time is not a physical object, well, what's this nonsense about time being warped? Okay, so they got a big problem there, and of course they say, well, that's the physical interpretation. You're not supposed to take the physical interpretation literally. You're not supposed to take space-time literally. What does that mean? That means you gave us a presentation. You said this is the mechanism, and then when we question your logic, to be nice with them, they say, oh no, but you weren't supposed to take it literally. Of course there's no such thing as space-time, or we cannot imagine space-time because it's four-dimensional, and I give you all this runaround. And you say, well, I just wanted to know why the astronaut fell to Earth. I got to explain that. How did the astronaut make it to Earth? And they say it slides along space-time because there's this depression. The guy has no other choice but to slide downwards into the depression. And you say, well, then space-time is some kind of slide, some toboggan, And he said, no, you're not supposed to take it literally. So they're running around in circles. You'll never get a straight answer from a relativist. what does there's another group, the electric universe, these deranged fellows, and they say, no, it's electricity, okay? And so here we have this electricity, and the guy's falling, the astronaut's falling through electricity, okay? And yeah, we have a problem with this. Obviously, it's nonsense. And you say, why? Well, because at least two reasons. The first one is they have no definition of electricity. You have the electric universe, they don't know what electric means. And here you have it, okay, I've presented it in the past. You can look it up there. Electricity is a fundamental quality of matters, so it is used to characterize other things. Thus, consensus opinion is lacking precision. In other words, we don't have a definition, guys. Like all bedrock presumptions such as gravity or time, reducing electric terminology into smaller units is impossible because it lies at the bottom of the lexical well. In other words, we don't have a definition, guys. But then they make some such idiotic statements like electricity, which we define as the flow, travels. So we have a flow that travels, okay? And then they use also words of incantation. They say electromagnetic energy flows. A concept flows, energy flows. Or they say electricity moves through a DC circuit in the wires as particles of charge. What do you mean charge? Charge, are these particles of love? Charge is a concept. Charge is a concept, and the electric universe has never learned that. And of course, when you confront them, they say, oh, you're playing semantics now. You're doing word wizardry, Bill. No, it just goes directly to their, I mean, you have to start with definitions. The other problem with the electric universe, why it's total nonsense, is these people are saying that all of space, the entire universe is full of particles, okay? So what they're saying is that we have a plasma out there everywhere. So when you go out into, when the astronaut goes out into space, he bounces against this plasma that's just covering him, smothering him. This is absolute nonsense. You have 10 to the minus 11, 10 to the minus 12 torr out there in space, on the moon, in the, in the solar wind. You cannot have a plasma with such low vacuum, okay? And, what can I say? And of course, you don't have a plasma, you don't have electricity. So this nonsense that the electric universe says that all stars and all galaxies are connected by filaments, absolute nonsense. Especially when they can't define, to begin with, they can't define their atom, just like we had with previously here. Just show me your atom. Electric universe just has to start with the atom. Show me a picture of your atom. I don't care the Mother Nature's atom. I want your atom, the one you're going to use for electricity. What are you going to use? A little bead going around the nucleus? Is that your atom? Is that how you're going to produce electricity? Charges going from atom to atom? Is that your irrational explanation for electricity? So no, they have to start at the atom. We need to find what the atom looks like before we can even listen to the electric universe, okay? And I like the last one better because we invited everybody to the seance, and one of the guys is from the Flat Earth Society, and of course they do it flat Earth-like. They have this astronaut just falling to to flat Earth. Okay, so yeah, you can choose that one if you think that's a better idea. Okay, how do rational folk do it? Here it is. Here we have the rope model. Okay, you can take it to the bank. Okay, this is why an astronaut falls to Earth. Every atom in his body is connected to every atom that constitutes the Earth. Okay? And now you can see why he falls at 9.8 meters per second square. In other words, why he accelerates towards the Earth. When you fall from an airplane without your parachute, you fall faster and faster and faster and faster. And that's why, because more and more ropes fan out from every atom in your body that's connected to every atom that constitutes the Earth. So you can see a mechanism now that you can understand, a physical mechanism. And so, the people in the seance say, well, Bill, but I don't believe in your ropes. They're just a concept. And I can't see them and touch them. I don't believe they exist. So you haven't explained the mechanism. Well, here's a rope. All ropes in the universe have shape, therefore qualifies as an object, just like the angel. Angel qualifies as an object, this qualifies as an object. So we got the object part taken care of. every atom is connected to the other atom, to all other atoms. That's an assumption. We make an assumption. Now we're going to explain the mechanism. The issue is not whether you believe that ropes exist. You can take that to your church. We don't care if you believe or not. It has nothing to do with what we're talking about. We're talking about mechanisms. Did you understand the mechanism? Here it is again. I just need to know if you understood the mechanism being proposed. If every atom of the astronaut is tied to every atom on the earth, we can explain why he accelerates towards the earth. Okay? That's what you got to understand. Do you believe in it? We don't care if you do or not, because belief has to do with religion. You can have your own religion. We don't care. You can have your own explanation. You can have a different religion. Doesn't matter. We just want you to understand the mechanism. That's what the seance was about mechanisms. Okay? Did you understand the mechanism? If you understood the mechanism, we're done. Whether you believe in it, whether you believe that ropes exist, whether you in your tiny mind believe that a rope is not a physical object, well, then you got a mental problem. You got to start by defining the word object. We need to know what you mean by object. And if you're going to say that the rope doesn't exist, it'd be nice if you would define the word exist as well. The two words we need to, in order to do physics. Okay? So you got two issues. You got to define the word object, and you got to define the word exist or real. Actuality, being, whatever you want to call it, doesn't matter. They're all synonyms. So two words, object and exist. Just define them, and then you can start criticizing. Until then, you cannot even begin. And then the other issue is that, this seance, this conference, whatever, was about mechanisms. If you understood the mechanisms, the conference is over. You can then go out there at the water cooler and talk about whether they exist or not. That's a separate issue. Right now, we're only concerned about the mechanism. Do you understand the mechanism? We can't understand the particle mechanism because it doesn't make any sense. We can't understand, the flat earth for sure. We can't understand the irrational electric universe mechanism because it's totally retarded, aside from the fact that they cannot illustrate their atom, so they don't have a starting point. They don't know what electricity is. They don't have a definition for it, so they can't even start. And for sure, we can't accept the God one because it's from distance. God just waves his finger. That's black magic. We can't understand the angel. The angel theory is the best one there out of all those. So the Catholic at least got his thing in there. He said, look, at least I could explain the mechanism. I did it with an object. I did it with an angel. But quantum, no chance. And general relativity, no chance. Electric universe, no chance. And flat earthers are just about at the same level as all of them. They're all in the same boat. With that, we'll see you, on Sunday? And hopefully we get back to Aristotle and Euclid. We'll see you then on Sunday. Bye.